All right, this problem here is one of the more difficult of the radical equation problems. And the reason it is because normally on one side of these problems you have a radical and then it equals maybe a number on the other side, and you square both sides and it makes this radical on the left go away, and then all the radicals are done. That's not what's going to happen in this problem. So let me rewrite the problem out and I'll show you what worked, what has to happen here. Alright, so we're going to square both sides, and you go ahead and you square both sides on this one because you do have one of the radicals isolated, and so when you square that radical on the left, that radical is going to go away, and this side is easy. The square root of something squared is just whatever's in the radical. Alright, so that part's easy. Here's the tricky part over on this side. You're going to square all of that. So just a little review here of a thing that I find that students are not normally good at. I'm just going to make up, let me get some totally different numbers here. 7x plus 3. If you square that, the common mistake here is that some students think, oh, I'm going to square that, and then I'm going to square that, and I'm done. And that's not what happens here. You actually have to come in here and do a FOIL on this. There's a whole rule about when you square a binomial what has to happen. And some of you may remember the FOIL process. You take this times this, that's the first times the first, and then the outer terms, and the inner terms, and then the last terms. And the reason some students think you can just square 7x and get 49x squared and square 3 and get 9 is because that is part of the answer. And some people mistakenly think that the middle terms cancel, but they do not. You have to take 7x times 3 and get 21x. Right? And you take 3 times 7x and get 21x again. They're not equal and opposite. They're equal and the same sign. So those add up to 42x. So there's a third term in there that's 49x squared is part of it. 9 is part of it, but there's also a 42x in this little hypothetical example I did out here to remind you of the rules of squaring two terms. We're doing that same thing right here in this problem. So I'm going to write out 5 minus the square root of x plus 2. And then I'm going to write it again, 5 minus the square root of x plus 2, because that's what we're doing. We're multiplying two binomials, essentially. All right, so the first term is easy. Everybody's pretty good with that. 5 times 5, that's 25. Okay, so that's the F in the FOIL process. Now the next one is to take the outer terms. This 5 times this negative square root of x plus 2. This is where people start to get flaky and fall apart and misunderstand. All right, so we're going to write minus 5 and square root of x plus 2. And so there's various things that people do here. Some people think that you can take the 5 and multiply it by the x plus 2. You can't do that. That whole x plus 2 is a little wad of stuff, and it can't be modified because it's inside a radical. The 5 is not. You can't crisscross between the two. I like to use the analogy that the x plus 2 is inside the house and the 5 is outside the house. You can't crisscross those two things. And so that's going to be ugly. That's going to stay just like that. We're going to have 5 times negative square root of x plus 2. And just like over here where we had 21x, guess what? When we do the inside, we get that same thing again. All right, so right here on the inside, I've got a negative, and then a 5, and then a square root of x plus 2. Okay? So you see how when you square a binomial, this always happens. The O and the I steps don't cancel. They actually double down. They repeat. So this 7x times 3 became 21x and 21x again, right? And then finally, the last step is the one that maybe you're more comfortable with. When I take the last terms, square root of x plus 2 times the square root of x plus 2, I got a negative and a negative, so that's positive. And whenever you square something, that's a square root, just like over here. When we squared the square root of x minus 13, you just get whatever's inside. So here I just get whatever was inside, and that whatever was inside was x plus 2. All right. And now let's continue here. I have 25. All right. So we look at these two things right here, and the way it works is these are just the same as like terms. We have a square root of x plus 2, and we have another square root of x plus 2. So we have negative 5 of that thing, and we have negative 5 of that same thing. So if you have -5 of a thing and -5 of the thing, then you have -10 of the thing. So it's -10 square root of x plus 2. So what I did there is these two terms essentially combined together. So -5 and -5 is -10, and then just write square root of x plus 2. Just the same as over here when I had 7x times 3 and I got 21x. And then I had 7x times 3 and I got 21x. You just took 21 plus 21 and made it 42, and then you took the x and put it on the end of it. It's the same process. I have a -5 here and a -5 here. Combine those and get a -10, and then just put the square root of x plus 2 on the end of it. And then finally we have plus x plus 2. All right, now we're finally down to where we have just one radical. So now let's do a little simplification here. I'm going to do some of my little baby algebra steps here. All right, so I have, let me switch to another color here now that I'm starting to do this algebra. So I'm going to say minus x, and then I subtract x over here, and well, guess what? They cancel on both sides. All right, and so I have -13 here, and let's see, I have 25 plus 2. All right, those are just regular numbers, so I can write that as 27, and then minus 10 square root of x plus 2. So let me subtract 27 from both sides, and so I get -40 equals -10 square root of x plus 2. Now again, since this 10 is outside of the house and this 40 doesn't have any radical, it's outside of a house. Right, I can work with those numbers, so I can divide both sides really quickly by -10 to make my problem a little bit easier. And so those two cancel out, and -40 divided by -10 is 4. So 4 equals the square root of x plus 2, and now we have a very simple problem. So I'm going to square both sides yet again, and so now this is like one of the easier problems we started with. So 4 squared is 16, and then square root of x plus 2 squared is just x plus 2. And so we take away 2, and we get 14 is the solution. Now you should always try to go back and check. Remember, on these problems, sometimes the answer that you get can actually work out to not be correct. That's part of the nature of radical equations. So my original problem said square root of x minus 13 equals 5 minus the square root of x plus 2. All right, so square root of x minus 13 equals 5 minus the square root of x plus 2. So when I substitute 14 in there, I get 14 minus 13 equals 5 minus the square root of 14 plus 2. All right, square root of 14 minus 13 is square root of 1, or just 1. And then I have 5 minus, and 14 plus 2 is the square root of 16, which is 4. And so this does check out. So x minus, or x equals 14 is the correct solution. All right. So hopefully you understood that. Again, the biggest issue I think for most people is up here in green where we do the FOIL steps and you have a number times a radical. You can't mix those two things together. Okay? I hope this helps.